Pulling your data from your freeze drive is a pretty simple operation. Let's reach behind, turn off the machine, go ahead and insert your jump drive, and turn the machine back on. The operation should take just a few seconds. So, pretty easy. That's all you need to do to retrieve your data. I'm going to go ahead and plug this into your computer to access the files. So I put my jump drive in my computer, and up comes this file that we all know that says harvest. And within this file are all the records for my Harvest Right freeze dryer. So we're going to go ahead and left click this, and we're going to open it up. And here's all the files. Now, my fast and standard mode was down here on the 28th and the 29th. So I'm going to come down here, and right here on 628 is when I did my normal mode. So we're going to go ahead and open this up by left clicking, and here's all my data. I went ahead and expanded my screen, and here is what we have. There is a whole lot of data, but I'm only really interested in a few different columns, and we're going to go through and reformat this so it's something a little bit easier to understand and to comprehend. So the first thing I'm going to come over here is where it says timestamp. It gets kind of cut off. So we want to expand all of our columns. Now this is pretty simple Excel spreadsheet stuff, but we'll try to go a little bit slow for those who are not familiar with this. I'm going to come up, I'm going to right click this column A. I'm going to highlight it all the way down to the bottom, and I'm just going to drag my cursor across and highlight all these lines until however far you want to go. I'm going to go ahead and release, come back here between the A and the B, where you see that little funny kind of a cross symbol. I'm going to hold down my left mouse, and I'm going to expand this out about that far and release, and that makes all my columns a lot wider. So now we can see all the headings up here on top. As we scroll up and down, we don't want this top row to disappear because this has all of our descriptions. So I'm going to highlight row number 1 by, once again, left clicking, and I'm going to come up here to view, and I'm going to come up here to freeze panels, and it says right here freeze top row. So I'm going to do that way. As the data scrolls underneath it, my titles at the top remain in place. The next thing, I'm going to come over here to where it says timestamp, and this is a decimal value method to display time, which to the normal person doesn't mean anything to us. So we're going to highlight column number B. We're going to right click and come down here to format cell, and we're going to come over here to where it says time. We're going to click time, and we're going to come down to this 13:30. That's the abbreviation for military time. We're going to pick that and hit OK, and now it changes all of our time into military time, which is a little bit easier to read. You can change it to the regular time, but I really don't like the AM, PM type of thing. I'd rather deal with military time, but you can format the time however you want. Now we're going to do a brief description of what these columns mean. Time start is when everything actually starts. So my normal mode that I performed started on June 28th, 2022 at 21:14 in the evening. And the thing about the Harvest Right, when it gathers data every minute. So here's the first minute, second minute, third minute. If you come over here, this is the time in which it gathered the information. So Now we have the timestamp is really just time. We have pressure, which we're going to hang on to. This next column over here, heat required, is basically how many seconds out of every minute was heat introduced or electricity was introduced into the heaters, if that makes sense. So if I were to come down here, let's see if I can come down here a little bit. So right here where it says heat required on at 1:56, at that particular minute, 25 seconds of heat was put into the heating pads, if that makes sense. It gets kind of complicated, and right now we're not worried about heat required, so we're just going to kind of ignore that for now, and we'll come back to it later. Same thing with the heater on. This is a call for heat. The system will call for heat under two different scenarios. It will usually call for heat at 500 millitorr, or it will call for heat if it's not at the set point in which you chose in the custom menu. But right now we're not interested in this column either. We are interested in this. The shelf T is shelf temperature. We're interested in that. This next column is the ambient temperature. This is going to be the temperature where the freeze dryer is located. So in this example, my shelf temperature was 71 degrees, and in my room or in my hallway where my freeze dryer, it is 76 degrees. We're going to skip H and I and come down here to the process. This is the process, which is sometimes is actually displayed on your Harvest Right screen. Of course, it does not display startup. That's just a label that Harvest Right placed in minute number 1. And then it has pre-freeze. It comes down to drain. Now what the drain is, this is the message that is displayed on your Harvest Right freeze dryer that it says close the drain, close the door, and whatever else it says. And as it goes down here, it has the freezing mode, which is displayed on the screen. If you go down even farther, it has vacuum freezing. This says freeze vac, but on the screen it says vacuum freezing. And if you go way down, it'll have dry ramping up, and drying LM is the same thing. And if you go even further down, I mean way further down, it's going to say final dry. So those are the messages, and we do want to keep this particular column. So what I'm going to do, I'm going to take this column J, which says process. I'm going to left click that. I'm going to right click and put down cut. And I'm going to come all the way over here to where it says G. I'm going to paste it in that location to get it a little bit closer to where I want. And then the heater on and the heater required heater on. I'm going to take these two, and I'm going to delete those. I'm going to go to my home tab and then come over here to where it says delete. Click that, and now they are gone. So the columns I want to deal with is going to be timestamp, which is time, pressure, shelf temperature, and process. With these 4 different columns, I'm going to build a graph, because a picture says 1,000 words, where just looking at this data, it's hard to really comprehend what's going on. Now, I'm not interested in startup. I'm not interested in pre-freeze. I'm not interested in drain, because this is just things getting ready to do the real thing, which is drying. This is a freeze dryer, and I'm interested in the drying mode of this process. So I'm just going to forget about all this stuff up here. I'm not interested in final dry, because at final dry, that's when everything is pretty much done, or could be done, and sometimes we add a little bit more extra time. So starting with this final dry, I'm going to come over here, and I'm going to click this particular time index. I'm going to come over here. I'm not going to include the title of final dry, just these 3 columns of time, pressure, and shelf temperature. I'm going to come all the way down here, highlighting all this data, and I just blew right by final dry. So I got to go back up here a little ways. Okay, and I'm going to come right down to there. So this captures all my drying. Then I'm going to come up here to the tab that says Insert, and we're going to go over to this little icon of a graph. I'm going to go ahead and click that on, and this is the graph I want to pick. So my graph right here is on the screen. It's a little teeny graph, not much to work with. So I'm going to I'm going to right click, and I'm going to hit cut, and my graph disappears. I'm going to go down here to the bottom of the screen where this plus sign is. I'm going to click that. This gives me a new sheet. I'm going to come up here to click in cell A1. I'm going to paste. Now this is my graph, a little bit too small to use, so I'm going to expand it to make it a little bit bigger. And there's my graph with all the data. Now I could come up here and I can type in normal mode, or you can just leave it alone. Down here, the blue where it says series number 1, this is vacuum, so the blue line is vacuum. This mustard color line is going to be his temperature. Now for this demonstration, I'm not going to rename series 1 and series 2. I'm going to try to keep this somewhat simple, but for those who are familiar with this program, you can go ahead and change some other things. The next thing I'm going to do, I'm going to put in some threshold lines at where our set point is going to be, and at 500 and 600 millitorr. I went ahead and added 3 lines. At 600 millitorr, I put a red line, 500 millitorr, I put a green line, and down here where I had to kind of guesstimate my set point, and I think this was 135 degrees, I put a blue line. Now, there's 2 things that control the freeze drying process, and that is either going to be the set point that is customized in the customized screen, and also it's going to be the 500 and 600 millitorr set point. When the heater reaches its set point temperature, the heaters will turn off. What will also turn off the heaters is when the vacuum gets to 600 millitorr, that will also turn off the heaters. One thing I do not know is I do not know what the tolerance, the plus or minus value for the heaters to turn off and on. So I don't know if the heaters will turn off exactly at 135 degrees, plus or minus, say 5 degrees. And coming up here, I don't know at what point the vacuum will turn the heaters on and off at 500 and 600 plus or minus so many degrees of vacuum. That is something that Harvest Rights knows, and I do not, unfortunately. At 500 millitorrs, it'll trigger the heaters to turn on to start warming up the food. As the heaters heat up the food, sublimation begins. And sublimation is when water goes from a solid directly into a vapor. And as it goes into a vapor, it creates atmosphere. And as it creates atmosphere, it goes from a low vacuum, say at 500 millitorr, up and up and up until it gets near or at 600 millitorr. So the water vapor is actually reducing, and you kind of have to think of this backwards a little bit. It's reducing the vacuum pressure by creating atmosphere. Once it reaches 600 millitorr, the heaters will turn off. And when the heaters turn off, sublimation will decrease or will stop, and then the vacuum pump, because the vacuum pump is running, will begin to increase the vacuum within the chamber. So you kind of have to look at that backwards. Once it gets down to this 500 millitorr mark, it'll come back down here, it'll turn on the heaters again. The heaters will heat the food and will start to sublimate, creating atmosphere. And when it either gets up to the set point of your set point temperature of 135 degrees, or when it gets up to 600 millitorr, it'll turn the heaters off. And as the heaters turn off, the food cools, sublimation stops, and the vacuum will start to build vacuum again. Now, what happens to the moisture from the sublimation? The majority of the moisture caused by sublimation, when it touches the chamber wall, because the chamber wall is below freezing, will freeze to the chamber wall. A very small amount of moisture will be sucked out by the vacuum and end up in the vacuum pump where it mixes with the oil. So this cycle continues back and forth, up and down, until we get to the point where there's little or no more sublimation. And as sublimation decreases, you can see the speed in which the heaters turn on and off will also decrease until we get down to this point right here. At this point, the system recognizes that there's no longer a change in atmosphere because there's little or no sublimation, and at this point the final dry kicks on. And what we can do, we can go ahead and we can graph what the final dry looks like by going back here into our data, and we can go down here and I can grab all the data for final dry, and I can come up here and make another graph. Okay, I went ahead and changed a few numbers around to make this a little bit better. But this is where final dry began. So we began final dry at just maybe 440 millitorr, and you can see where the vacuum continues to drop and drop and drop because sublimation is really no longer occurring, and it keeps on dropping and dropping and dropping, taking every little bit of moisture that's going to be in our food out of the food. And you can see down here where the heaters are going off and on, off and on. Just really, the heaters are now cruising. They're just nice and happy and doing the thing that they need to do. And then if you take a point at this point right here, this is when I stopped the freeze dryer. I opened up the valve, and when I opened the valve, of course, I lost all the vacuum pressure. I checked my food, and I guess my food probably wasn't quite done yet. And so I shut the door, shut the valve, turned the pump back on, and you can see where the vacuum pressure came back down and the heaters continued to run, and then eventually stopped at this point right here at 4:42, I believe, the following day. So I'm back to my data, and now what we're going to do, we're going to go ahead and take a look at what happens on the fast mode. This is my fast mode data, and I'm going to go ahead and prepare my chart to make it a little bit easier. So just like in standard mode, this is fast mode, and it's going to take, it collects data for every minute that the freeze dryer is running. So I'm going to take a look. We're going to go ahead and capture the time, pressure, and the shelf temperature, and do the same thing we did as in standard. We're now looking at fast mode. I went ahead and added the blue, green, and red lines again. And you've noticed that this is a little bit different from the other wave pattern we had in standard mode. So in fast mode, we're still looking at vacuum where vacuum controls everything between 500 millitorr and 600 millitorr. So at 500, when it hits 500 millitorr, the heaters turn on, and then when the vacuum reaches 600 millitorr, the heaters are turned off. So as the heat turns on and it starts building up to my set point of 135 degrees, it starts going through this cycle of getting warmer and warmer and warmer. It's giving this constant surge of heat until it reaches at this point up to my set point. Meanwhile, up here, we're getting sublimation. We're creating atmosphere inside our chamber that is getting greater and greater and greater. And at this point, once it hits 600 millitorr, then the system tells the heaters to shut off right down here. And you can see where the heaters are now shutting down and things are just kind of resting, and they're just kind of coasting back down to a cool temperature. And as the heaters start to cool down, sublimation slows down and stops, and you can see where the sublimation starts slowing down until it gets down below this 500 mark. At 500 millitors, then the heaters turn on again. Right here, they're turning on, and it's going to heat up really, really quick this time. And as it does, sublimation begins a little bit faster, a little bit quicker, until it reaches its apex at 600 millitors. And then it tells it down here, go ahead, take a break, relax, rest for a while, and the heat starts to cool down. But this is like a real sudden surge of heat, where in the standard mode it's more consistent. We're just kind of just cruising along, just mellowing out, doing what we need to do. But in the fast mode, it happens all at once. And so we have these two big surges with heat and sublimation that doesn't happen in the standard mode. So as it continues on through the batch cycle, you can see the heat going off and on, up and on. Now there's two things that will turn off the heat. The one thing that will turn off the heat is when the vacuum reaches 600 millitor. At 600 millitor, the machine will turn off the heat. The other thing that turns off the heat is the set point. So you can see where it comes up to 135 degrees and automatically turns the heat off, and it goes down again, it builds up, hits 135, turns off. So you can see where this cycle is happening, where we have this constant cycle of heat, and as we have this constant cycle of heat down here, you can see where there's more and more sublimation, and it gets to the point where most of the moisture now is no longer in the food, and it gets to the point where it falls under 500 millitor, and it keeps on dropping and dropping because there's no more moisture, no more ice crystals to sublimate, to turn into vapor. And at this point, the machine goes into final dry, and we've seen once before what final dry looks like. So how can this help troubleshoot a freeze dryer? Well, remember, 500 millitor is like the magic number for freeze drying. If your freeze dryer cannot get down to 500 millitors, there's a good chance that the heaters will not turn on. And if the heaters don't turn on, you're not going to get sublimation. And if it doesn't get down to 500 millitors, then you're going to come up with that inadequate vacuum message that we all know and hate. So that's one of the issues with the 500 millitor, is if you don't reach it, you won't get into sublimation and your food will not dry. Just when I was getting ready to wrap up this project, I got a couple of inquiries on my YouTube channel concerning the fast mode versus the normal mode. Now, in my original video concerning that, I was only concerned about the quality, texture, of the taste of the two different foods that were freeze-dried under fast and normal mode. But a couple of individuals wanted to know a couple of questions. One is, how long did it take to do the fast mode versus the normal mode? So we're going to go back to the data, and I went ahead and already graphed this out. So we have the normal mode up here, we got the fast mode up here. Here's our starting point for both, right here, and our ending point is way out here and right here. Now, one of the problems, because we're dealing with 500 millitor, the blue graph, the blue line, which is vacuum, you can barely see it. So I'm going to have to come in here, and I'm going to have to adjust this this legend right here, so we can actually see the blue, the difference between the blue and mustard lines. So I'm going to have to adjust this, and we'll then observe and calculate the time. So I went into the data and into the graphs, and I altered the axis here to only go up to 700 millitor on both the fast and the normal mode. And I put in some pretty colors. So this pale yellow color right here, this is that first basically 15 minutes of that initial freeze that the new program, version 19, now has you go through. So there's 15 minutes here basically, and there's 15 minutes here. That also includes part of the drain cycle. Now, this brown color right here on normal and on fast mode, that is all the pre-freeze and the vacuum freezing moment. So as you can see here, in the normal mode, it's actually a little bit smaller than it is in the fast mode. But where we really start to make the big difference is in the drying. In the normal mode, which is this light green color, the normal mode, the green color is much larger than it is in the fast mode. And the reason I originally made my graphs just to include this section here and this section here in my other graphs is because when the machine senses no more sublimation and goes from drying to the extra dry time is right here for normal and right here for fast. So basically there's no more sublimation at this point right here. Now on the fast mode, this is at 278 minutes or 4.6 hours. In the normal mode, this section, the point right here is 346 minutes or 5.8 hours. So the fast mode actually dries faster than the normal mode. Now, if you go back to my original video, what does that do to the quality of food? And please, may I remind you, no wagering. So, with the milk, fast mode versus standard mode, well, the results are all standard. Everyone liked the standard milk much better than the fast mode milk. They kind of said the fast mode was a little bit more watery than the standard, and the milk was reconstituted gram for gram. Tomatoes. This is a real big contender. A lot of people don't like freeze-dried tomatoes when they're reconstituted because they get kind of soggy. But anyway, the results for the tomatoes was split. They liked the standard mode a little bit more than the fast mode. Mixed vegetables, depending on how you like your vegetables, your broccoli, your carrots, cauliflower, a little bit of everything mixed in here, the results were all fast mode. And this kind of surprised me. I thought that the standard mode would have done better. Cheeseburger, one of my favorite little things to do. The results for cheeseburgers was a big sweep on standard. So basically, you could say that maybe standard does a better job on meats. Sliced turkey breast. Now, if the cheeseburger won on standard, how do you think turkey breast is going to do? Well, it was a split vote. 2 votes for fast mode and only 1 vote for the standard. Going to shredded cheese. Fast mode or standard? Well, fast mode won again on the shredded cheese. Shredded cheese is a little bit harder to reconstitute, but that's why we used a spray bottle and just did a little water at a time so it wouldn't get mushy. What does this all mean? Well, there's a fast mode and there's a standard mode, and I would urge you to try this test yourself and see what you like. What kind of foods do you like under fast mode and standard mode? Fast mode seems to be the most popular. It's the quickest mode. Standard is a little bit slower, but in some cases, some people think the standard mode may do a little bit better. But it may not just be the mode. I think a big part of this is how the food is reconstituted, and we're going to be covering that later. Now here's a bit of a problem when it comes down to extra dry time. Extra dry time is somewhat subjective to all sorts of different things. So this section right here is nothing more than extra dry time. So on normal, the normal mode went 1,174 minutes. On the fast mode, it went 1,084 minutes. So even with the extra dry time added, fast mode is still faster. So if you take a look at this right here, this is where the door was open. This is where I paused the machine, opened the door to check for food. And then the door was shut and extra time was added. And right here you can see where the door was opened and the machine was stopped. So basically, I felt at this point, with the extra dry time, the machine was ready to be turned off and the process would be complete. But up here, I checked it here, did not feel comfortable with the food, and I went to this point where everything was shut off. But this really is not a good factor in determining if the food was dry or which was completed or not. If we go back here to where the sublimation ended, this is going to be a better point in when the food was dry, when sublimation stopped occurring. I hope that makes sense. The next question I had is, how much did it cost to do the normal mode and the fast mode? Now, just one little bit of a tidbit here. My trays were not full. In fact, I only freeze-dried, I believe it's 1 or 2 trays of each food, just a little bit of a sample. So another viewer sent me a comment. His name is like Zigzag something or other, but he wanted to know how much power did it take to run this batch from normal mode down to fast mode. Now, when I did this sample, I only had partially filled trays of food, and that's one of the reasons why it dried so quickly. The trays were not filled to maximum capacity. So using the data here, we can go back and take a look at how much time was used to do this. So if we go at the very beginning, which is, this is going to be minute number 1 right here, and if we go all the way down to the bottom, we can determine that on the normal mode, it took, for total time, is 1,174 minutes. But the issue is during these cycles, not everything is running at the same time. Now, at this point right here, the vacuum pump turns on, and so we have the vacuum pump running from this point all the way down to this point. But what we're really going to do, we're going to say that everything was finished at this point right here, because this extra dry time, once again, is kind of a weird thing to try to pin down. So to the person who filed the comment in my YouTube channel, which is, if I hope I can get this right, Valcron11. So basically, for the answer for them, normal mode was 5.8 hours and the fast mode was 4.6 hours. Now, another question that was submitted to me was from the Ziggy, and he wanted to know, how much did it cost? Well, we can answer that too, going back to the data, but it's not, I'm not sure how accurate it's going to be, because we have this whole issue here with extra dry time. But it's easy to calculate how much it costs from the beginning here to when sublimation stopped, and technically speaking, the food was probably dry or near dry, and the same thing down here. But we can tell already that the fast mode was faster than normal mode. In another video I did called Location, 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 I did use an amp meter to determine how much power the refrigeration unit used, the heating pads used, and the vacuum pump used. Now, at this point right here, when you first turn on your freeze dryer, the refrigeration unit comes on and stays on until the process is complete. So we can go from this starting point to this ending point. Now, during this point right here, where it has vacuum freezing, and I'm going to have to go back in here and recalculate when vacuum freezing started, that's when the vacuum pump starts. So the vacuum pump starts somewhere in here and went to this point when sublimation ended, and so we can calculate that out as well. So I went into the data and I calculated when the vacuum pump turned on, which would be the vacuum freezing stage. And on fast mode, it started right here and would end when final dry would start. And on the fast mode, it started right here and would go until the extra dry time on the fast mode would start. Once the numbers were crunched, this is what I have. For normal mode, we have total refrigeration ran for 345 minutes. Heat ran for 177 minutes, and vacuum ran for 207 minutes. Now on the fast mode, refrigeration ran for 278 minutes, heat 144 minutes, and vacuum 111 minutes. Now we're going to convert these to hours and then convert those to kilowatt hours and times it by the price per kilowatt hour. I gathered all the information on amperage for refrigeration, vacuum, and heater. And basically, to get wattage, you take the amperage, times it by the voltage, and you get watts. And then I took the hours that each individual cycle or mode ran, and then came out with total wattage divided by 1,000 to come up with kilowatt hours. So I have for the normal mode and for the fast mode, each refrigeration, vacuum, and heater. You can see it all right here. And once everything crunches out, the normal mode came up to 6.1 kilowatt hours. Fast mode came up to 4.2 kilowatt hours. And I get charged just a little bit under 9 cents per kilowatt hour. So the short little cycle that I did, and I got to also stress that when I did this freeze drying cycle, I was only freeze drying 2 trays that were barely loaded, and it didn't take much time at all. So the normal mode took 53 cents, the fast mode took 36 cents, and once again, these calculations do not include extra dry time. This is where the cost of running the freeze dryer is really buried into, because during the extra dry time, which can run anywhere from 2 hours to 12 hours, you have the refrigeration unit running, you got the vacuum running, and you have the heater running. So this is where the cost of running a freeze dryer is really found. This is where it gets really expensive. So a normal mode for me usually costs about $3.50. But for my little experiment to dry my food to test between normal and fast mode was only that amount. If you found some kind of value to this video, I know it's not exciting stuff, it's not sexy, but if you can understand your freeze dryer a little bit better, you might be able to run it a little bit more efficient. So thank you for your time. Please subscribe and go forth and freeze dry the world.